Good afternoon, all of you. In today's session, we are going to start with the 10th standard chemistry and physics. Unit 9, electrical current is going to be discussed, and series number 1. This is the very first series of this unit. Electric current is going to be discussed. Earlier, we completed unit 1 to 8, entire detailed explanation available on the channel called World of Competitive Chemistry. In this session, we are going to discuss about what is meant by electrical conductor, what is meant by insulator, and the revision of the previous content, what you learned in the earlier classes. So those topics are going to be recapped, and also kind of activity is going to be performed where the illumination of lamp is going to be done. Let us enter into our today's concept, electric current series number 1. Right. So we are going to recollect our previous knowledge, whatever we learned in the earlier classes. In the previous classes, you had learned about the electrical current and also battery, electric circuit and its components. What is meant by electrical current? How the current passage is possible? The flow of charge from one place to another place, the units are mentioned in amperes and equal to that of 1 coulomb per second is called electrical current. So just we are switching on, what happens, the illumination of bulb is possible, that extent spontaneous the reaction it will be, and moving from one region to another region is possible, and which is measured in amperes, that 1 ampere exactly is equal to coulomb per second. So this is denoted as electrical current. Then how the electrical current is originated and what will be the direction of flow? What happens when we are connecting one battery with a conducting wire? What happens, the current from this battery is moving to the bulb, and there is illumination of bulb is possible, and from that again it is moving in this direction too. So this is a kind of circuit. What happens, current is passing from this battery to bulb and also bulb to battery, so the circuit will be completed. So this will be the direction of flow of electrical current is possible in general, and electric current is nothing but flow of charge. Now, let us discuss what is meant by battery. Battery is nothing but it is consisting more than one cell. So when different cells get connected in a series, that what happens, chemical energy get converted into electricity, and it will become a source of power, right? Where electricity origination is possible, and these batteries are used to illuminate, and not only illumination, but also for various applications in the domestic, industrial, and also transportation, automobiles, all these. We are using these battery nowadays in the larger extent, and they are used to give the instantaneous energy at the expense of chemical energy get converted into electrical energy. Now, in the previous classes, you had learned about the electrical current, battery, electrical circuit, and the components. These are said to be electrical circuit components where battery can be taken and the bulb is required, and another wires are needed in order to supply the current from one region to another region. Those are said to be conducting materials. An electrical network is an interconnection of electrical components or the model of such interconnection consisting electrical elements. Circuit is a network consisting closed loop where the return path for the current is possible. Electric circuits are made in different ways like this. Here, single bulb, otherwise multiple, can be connected with a series from the single battery. So many kind of applications we have by taking battery in order to illuminate, by making this interconnection of all these components to in order to create the electrical circuit. Now, in the previous classes, an electrical network is an interconnection of electrical components, and here is the simplest model provided to us. Battery was taken and a switch is there in order to make a optimization of movement of current, whether to stop or flow. So for that purpose, this works like a valve in order to switch on and switch off, so that here current passage. Otherwise, a charge passage is possible from this battery to the light, so that illumination of lamp is possible, right? Here, an electrical circuit is a network consisting closed loop. So here you can clearly observe it is a circuit. Within the system only the charge transportation is possible, so that light glowing is possible. Now, electrical current, how it will be originated and what will be the units for that one, and the detailed explanation is going to be provided in this. What do you mean by the electrical current? In order to explain explain this. The electrical current is the rate of flow of charge in a wire or through the component. So when you are taking a light which is present in your particular area, what happens by switching on, what happens, and illumination is possible. That is possible because of the flow of charge through the wire, otherwise through any other component too. So most probable we are taking wires for the conduction of current. In general, copper will be taken. So there is an interesting factor, even though highest conductivity is assigned for silver, but copper was taken as the electrical conductor in general. What could be the reason for that one? Because copper is abundantly available and may not involved in any kind of rusting process and efficient. So next to silver, this is the most efficient conductor of electricity. That's the reason why copper wire is mostly used for the conduction of current. And electrical current is measured in amperes, which is denoted with capital A. Due to the passage of charge, particles referred to as the charge carriers. Those are carrying the charge from one place to another, that is said to be a charge carrier. For example, if you are passing through the copper wire, that will become a charge carrier. If you are taking metal, any metal other than copper also you may take, but the extent of conduction will be different for different kind of metals. So these all metals are regarded as a charge carriers because we are taking metal as a for the conduction of current. Because the metals are having the free electrons in order to pass. How the water moving in a pipe, in the similar manner, electrons are passing through the metal, so that conduction is instantaneous. Within the sharp span of time, the illumination of lamp is possible without any interruption. On the liquids and gases, the charge carriers are ions. If you are taking sodium chloride in the beaker and connecting with the two different electrodes and which are connected to the bulb again, that will become luminous because the ions are moving in the different directions, so that here light glowing is possible. This is also regarded as the passage of current. Conduction may possible through the passage of electrons, otherwise there is a possibility of ions as well. So in this manner, current is nothing but flow of charges through the wire or any other component, can be measured in terms of amperes. And any other question we are posing here, which type of charge, either positive or negative, flows through the electrical wire when it is connected with the electrical circuit? Here, in general, what we can observe, current is nothing but flow of electrons. Flow of electrons, nothing but negatively charged particles are moving, but not positively charged particles. If you are taking copper metal, working as a conductor of electricity, if you are switching on, what happens? Electrons are moving, but not copper. Copper remains at that place only. That's the reason why copper ions will not migrate. Only the passage of electrons are possible in general. Only the positive charges will not be mobilized, rather negative charge will pass in order to conduct the current in metallic conduction. But that will be different for electrolytic conduction, where two oppositely charged cations and anions should move in opposite direction. Then only circuit will be made, then only flow of electricity is possible, right? Here, electron flow notation is represented in this manner. We are taking the switchboard, for example, from which this negative turn used to supply the electrons, so that here electrons are moving in this direction. The direction of flow will be like this. If you are putting a bulb at this place, that will become luminous because it is gaining electrons from this source. So let us say this is a battery. So now this will flow in the same direction, and in order to reach the positive end of this circuit, so the circuit will be closed, circuit will be completed. In this manner, current conduction is possible. In general, negatively charged particles are moving. They are seamlessly regarded as electrons. Now, let us see the live example with respect to the conductivity. Is there any evidence for the motion of charge in a daily life situation? Absolutely. Lightning is the simplest live example, and I collected this answer from .NET. Thank you very much for your valuable information. Here, lightning is nothing but when clouds where the charged particles are used to rub with each other, that used to generate the electricity. So that is the general example for the origination of electrical current. High voltage power generation is possible in this manner. This is the simplest live example which we can notice at the time of rain precipitation. In the class 8th, you learned about the lightning. Lightning is electrical discharge between the clouds and earth, clouds and earth, that is called is also having high extent of energy, high voltage will be possible with this. This electrical discharge through the air appears to us electrical spark or lightning. Lightning is a live example which provides evidence for the motion of charge in the atmosphere. How the motion of charge is possible, that is the live example where lightning is observed when the rain fall is possible. This is the simplest example, and I would like to add one more example to this one. Human being is also considered as a conductor of electricity because so if we are going to supply any electricity through us, what happens, that used to transport from one region to another. That's why we are experiencing electrical shock, right? That is purely because of we are having so many electrolytes in water which used to conduct the electricity, so that we are also the live example for this motion of charge. So, and does motion of charge always leads to the electrical current? Always, the passage of charge used to give the electrical current. So I collected this answer from Topper's answer. Thank you very much for your valuable information. So never. The charges in motion constitute an electrical current. However, not all moving charges constitute an electrical current. An example for it is a flow of free electrons in the copper wire. So all moving particles may not responsible for the passage of electrical current, but a few particles, especially copper wire, is flowing electricity, but not all the cases. So this is the answer I collected from Topper. And always it is not possible to collect the electrical current passage. And we are going to perform the activity based on this conduction of current, and we are performing various situations based on the requirements in order to do this activity. So first we are considering situation 1, where the ingredients which are required to perform the activity are electrical bulb is required, and one of the battery is needed, and electrical switchboard, and either conducting material like copper wire which is properly insulated. All these materials I collected for this activity, right? I take a bulb and a battery, switch, a few insulated copper wires, all got collected here. Then connect all the ends of copper wires to the terminals of battery through the bulb and switch. What we are doing, we are taking the battery, and these electrical wires are connected to the terminals of this battery, and they are again arranged and attached another terminals of these copper wires now attached to the electrical bulb in between, in order to monitor, in order to maintain the electrical flow. So here switchboard is also inserted in between. Now switch on the circuit, observe the bulb. So if you are going to switch on this one, what happens, and what is the inference which is drawn from this activity? What we are doing, we are taking a battery, and also electrical wire was taken, that is made up of copper, that is properly insulated, right? So, and this will be inserted with the switchboard, and also the terminals of these electrical copper wires are connected to the bulb. And we are going to switch on this one, and what kind of observation you are going to see, right? In the situation 1, what we are doing, all are connected in such a manner. This is a battery, and the switchboard got connected, and these electrical wires finally connected with the electrical bulb. You can observe this bulb is becoming luminous. It's glowing now, because here battery is the source of energy, source of power, which used to supply the electricity in such a manner with this conducting material called copper, so that here light is receiving electricity and it will become luminous. So this is a kind of situation 1, and it is illuminated. So here glowing bulb we can observe if we are performing this activity in such a manner. Now, we entered into another situation called situation 2. Remove the battery from the circuit and connect the remaining all the component, complete the circuit, again switch on the circuit, observe the bulb. Can you find any change in the glowing of that bulb or not? So here 2 conditions are provided to us. In general, the luminous bulb will be represented, and the non-luminous is also represented. What we are doing, same kind of circuit we are making without this battery. Battery is removed, remaining all the components remain same. Then obviously battery will be the source of power. If we are removing battery, it is not possible to glow this bulb, so that it will not be glown. right? The bulb does not glow. The battery contains the charge which glows the bulb. Battery only the source of power in this experiment. That's the reason why here, if we are removing that one, this bulb is not able to glow. So, and we entered into third situation in this activity number 1. Replace the copper wire with a nylon wire. Same activity, the whatever activity we performed here, taking battery and a copper wire and the switchboard inserted in between, and both the terminals connected with the electrical bulb. In this condition, this copper wire now replaced with the nylon strip. See, here replacing copper wire with the nylon wire, they connect the nylon wires to the terminals of the battery through the bulb and switch. Now switch on the circuit and observe the bulb. What could be the inference you are going to draw? Obviously, nylon being it is a plastic material, it is a polymeric material made up of organic moieties, and it will be the better insulator. So being it is an insulator, it can't allow the passage of current, so that here glowing a bulb may not be possible in this experiment. Now, after doing this activity, you will notice that the bulb glows only in the situation 1. This is the inference we drawn from this activity. Situation 1, where we are taking battery, copper wire, switchboard, and connected with the electrical bulb, so it will become luminous. This is very clear. And the second condition, we are removing that battery so that glowing is not possible. And the third condition, we are replacing conducting material with another called a nylon wire, so that here conduction may not be possible, right? So here only situation 1 is capable to give the glowing bulb, so that here the requirements are the essential materials in order to glow the bulb are: one bulb is required and energy source. Not only battery, any other energy source may be required. Switchboard is required in order to optimize the voltage, and any other conducting material is also important. These are the required materials. Now, can you predict the reason for the bulb not glowing in the situation 2nd and 3rd? What's the reason? The second condition, we are removing battery, right? So when battery removed, what happens? Battery is a material, is a source of energy where chemical energy get converted into electrical energy. And this battery alternatively known as electrochemical cell, where current production is possible at the expense of chemical reaction, right? That's why battery is very essential in this glowing of current. And class 7th, you have learned about the battery stores the chemical energy, and this converts energy into electrical energy and makes the bulb to glow, and that is clearly observed in situation number 1. Then the battery supplies the required energy to make the bulb glow, so that here when wire directly connected to the bulb, from this battery energy is supplied, so that bulb illumination glowing is possible here. Now, but in the situation number 3, though there is a battery in the circuit, the bulb does not glow because the connecting wires are not able to carry the energy from the source to bulb. Because whenever there's a battery is connected with the nylon threads, what happens? Being nylon is an insulating material, there is no any charged particles present. So charge transportation may not be possible. That resists the movement of current. That's why no power will be supplied. So luminous bulb will not be observed. Rather, so this will become non-luminous. And hence the nature of the substance plays an important role in the transfer of energy from the battery to bulb. The material which transfer the energy from battery to the bulb is called a conductor. So which pass the current, that is called a conductor. The material which cannot transfer the energy are called insulators, which are alternatively known as non-conductors. So if you are taking copper wire that used to carry the charge, that used to glow the bulb, so that you can say that is the better conductor of current. In case the materials, I'm taking simplest example here, copper wire was taken that used to glow the lamp, so that you can say this will be the better conductor of electricity. In the second condition, we are taking nylon wire where conduction of current may not be possible, and it will be the bad conductor of electricity, and being it is an insulating material, conduction or carrying the charge may not be possible, so that the light becomes non-luminous. So here copper is a conductor, and this nylon will become a non-conductor, which alternatively known as insulator. This is the activity which is performed based on the conduction of current and how the bulb is glowing by taking the set of requiring components in order to glow that one. And why do all the materials not acts as a conductors? Why all not materials? When copper was taken, bulb is glowing. When nylon was taken, bulb is not glowing. What could be the reason for that one? In order to explain that, we have to know the detailed explanation about how the conduction of current is possible. So all metals are very, very good conductors of electricity. So as already we know, around 75% of elements which are present in the entire periodic table are regarded as metals only. That's why greater the extent of elements in the periodic table are able to pass the current from one region to any other region, right? The reason will be when metallic bonds are there, metals are being all associated with a very close arrangement, and all electrons present in the metals are loosely bonded. Valency shell electrons being all metals are electropositive in nature, electrons are loosely bonded on its surface, so that they the movement of electrons are very free. How water moving in a pipe, in the similar manner electrons are moving in a metal. That's the reason why they are used to pass electrons from one place to another. Electron movement is nothing but current. So that's the reason why when we are supplying current from one source, these electrons are simultaneously displaced so that conduction of current is possible. In any other case, when we are taking sodium chloride again and add it to water, so that sodium any place and chlorine Cl minus formation is possible in the water. And in that case, the conduction is possible with the origination of such charges. These charges are moving in opposite direction and used to generate the voltage. That is the reason why here electrical conduction is possible. Conduction is mainly possible by the passage of current, otherwise by the passage of ions, positive and negatively charged ions. This is called metallic conduction. This is called ionic conduction. Charged particles mentioned above are called ions in the solutions. They are also responsible to pass the current from one place to another place. So that's the reason why all metals are able to pass the current, and also ionizable substances are able to pass the current to too. Now, another question arises, and some of the materials are not conducting current. Those are regarded as insulators, alternatively known as non-conducting materials. The simplest examples are plastics. All plastics are regarded as insulated. That's why we are keeping them in order to avoid the power, what we can say, fluctuations, any kind of short circuits, all can be avoided by these insulating materials. Always copper wire is surrounded with plastic material because they are insulating. They used to avoid the corrosion, they used to avoid the power fluctuation, they used to avoid the loss of current. That's the reason why plastic is efficient insulating material. Even rubber is also regarded as insulating material for this one, and wood is also the best example for insulating material where current passage may not be possible. So all these are, when current is supplied to them, they are not able to pass from one place to another. That's the reason why these are regarded as non-conductors of electricity. So by this, we completed the activity, whatever we performed by taking the circuit like a battery and copper wires, a switchboard, and also another bulb. So in different conditions, how the bulb glowing is possible, what are the required essential materials in order to glow the bulb, and what is the principle behind this whole execution of this activity. Entire things were discussed in this session. Hope this will be helpful for your preparation. Thank you very much for your consistent listening. Thank you, one and all.